at normal temperature. The reason behind that, see in this reaction, if this reaction goes to the forward direction, H and OH bond break. In the backward direction, H and OH bond form. So can we say forward reaction is endothermic, forward is endothermic, and backward is exo. So if the reaction goes forward direction, energy is absorbed. If the reaction goes backward direction, energy is released. Now see the effect of temperature. If I increase the temperature, can we say that if we increase the temperature, that means we are adding energy. If we are adding energy, that means it proceeds to the endothermic path. So it goes forward direction. If it goes forward direction, the concentration of H and concentration of OH increases. So let's say I have raised the temperature to 60 degree and the concentration of H plus, let's say 10 to the minus 6, 10 to the minus 6. Now the Kw become 10 to the power minus 12, isn't it? And the pH at this moment is 6. pH at this moment is 6, but the solution is neutral. If I increase the temperature and it decrease to 10 to the power minus, increase to 10 to the minus 5, 10 to the power minus 5, then the pH will be 5 and the solution become neutral. That means if I increase the temperature of water, the pH decreases, but the solution is neutral. If I take ice, temperature at minus 2 degrees centigrade, the Kw decrease from 10 to the power minus 14 to 10 to the power minus 18. At that moment, the concentration of H plus is 10 to the power minus 9, OH is 10 to the power minus 9, pH is 9, but the solution is neutral because both the concentration are same. But in case of H2S, if I add H2S in water, it will give H plus and HS minus, right? So it can increase only one ion, that is H plus. Okay, so H2S is always acidic. H2S is always acidic and it undergo two type of dissociation. One is H plus plus HS minus. Second is HS minus dissociate to give H plus and S2 minus. Combinedly, we can say H2S can give 2H plus and S2 minus, which is K1 into K2, that is known as equilibrium constant of this H2S, right? So H2S become acidic. Now, as I move down the group, the conjugate base H2S form conjugate base of HS minus. H2S form conjugate base of HS minus, and water form conjugate base of HO minus. The conjugate base has tendency to accept this H plus. Now, how we define the strength of conjugate base? Any atom which consists of negative charge, we say it is conjugate base. If you increase the size of this negative charge, sorry, if you increase the size of this atom, if you increase the size of this atom, the intensity of negative charge decreases and the strength of conjugate base decreases. Strength of conjugate base decreases, and result will be the respective acid will be more acidic, more acidic. See, H2O, the conjugate base is H2O, the conjugate base is OH minus. For H2S, the conjugate base is SH minus. For H2SE, the conjugate base is SEH. For H2T, the conjugate base is TH minus, right? So as I move down the group, the size of atom increases. That means this negative charge decreases. That means this is weak conjugate base, this is strong conjugate base. Weaker the conjugate base, higher will be the strength of acid. So among H2O to H2T, highest acidic nature is H2T. So can we say as we move down the group, the acidic strength increases. See the value I have not mentioned. The Kw for water is 10 to the power minus 14. Similarly, the KWH H2T is approximately 10 to the minus 8, in the range of 10 to the minus 8. So H2T is acidic in nature. All these hydrides are colorless, odorless liquid. Colorless, odorless liquid. The thermal stability decreases as we move down the group. The most stable one is H2O, and least stable is H2T. Why most stable is H2O? Because H and O bond is stronger, whereas H and T, the bond length is very large and it is weaker. So thermal stability means at what temperature it undergo dissociation. So the most stable is H2O. Thermal stability always for almost all hydride decreases down the group. Clear? The third point is bond angle. See the hybridization of water. Hybridization of water is sp3, isn't it? So what will be the bond angle? 109. So that means if it is sp3, the hybridization is 109 angles. Hydrogen, hydrogen, lone pair, lone pair. We know that the repulsion between lone pair is maximum as compared to lone pair, bond pair, as compared to bond pair, right? So this lone pair repulsion is maximum. To compensate this repulsion, these bond angle will be decreases. So this bond angle decreases, right? Clear? Now, why this bond angle decreases? See, these electron repel these electron because they are negatively charged. See, if I increase the bond length, this atom, central atom and hydrogen, bond length increase. That means the electron density in this bond is decreases. If the electron density in this bond length is decreases, the repulsion decreases. Can I say increase the bond length decreases interbond electronic repulsion, due to which the bond angle decreases, so that these lone pair can get higher space. So in these hydrides, the bond angle decreases as we move down the group. Clear? Why the bond angle decreases down the group? Yeah. See, H2O, the bond angle is 104, H2S 92. The difference is very high. H2SE 90, H2T 90. Clear? Clear? So there are four things. One is thermal stability. Thermal stability decreases down the group. Second is acidic nature, increases down the group. Okay. Third is bond angle, decreases down the group. Okay. Fourth is pH, it decreases down the group. Water is neutral. Okay. Fifth is equilibrium constant for their H plus donation. It also increases down the group. More acidic, higher Ka. Clear? See the equilibrium constant, which we have already discussed, is mentioned. The equilibrium constant of H2O, 1.8 into 10 to the minus 16. Yeah, this is not equilibrium constant, this is K. There is a difference between equilibrium constant and K. In K, let's say you have taken 1 liter of water. 1 liter of water means 1 kg of water. 1 kg means 1000 gram. 1000 gram divided by 18 is 55.5 moles. So 55.5 mole undergo dissociation at 25 degrees centigrade to give alpha. So 55.5 minus alpha, that is 10 to the minus 7, 10 to the minus 7, 10 to the minus 7. You divide 10 to the minus 7 square multiplied. I'm saying that H2O dissociate to give H plus and OH. 1 liter means 55.5 moles. 55.5 minus alpha. We know that the value of alpha is 10 to the minus 7. So put 10 to the minus 7, 10 to the minus 7. Generally, we used to neglect this value, right? But in the KW, you write H plus into OH minus, unable to divide this water. In the Ka form, you divide 55.5. So the value is 1.8 into 10 to the minus 16. See, the value is 10 to the minus 7. 10 to the power minus 4. See, this is 10 to the minus 3. H2TE, the value is 2.3 into 10 to the minus 3. You know the value of Ka for HF. It is approximately 10 to the minus 2. So it is similar acidic as compared to HF. Clear? So the stability as well as the reactivity of hydrides. Now, third point is reducing character. Reducing is simple, that all hydrides except water are reducing agent. The reducing power increases down the group. Why reducing power increases down the group? Because the bond length increases, so it is easy to donate H minus, right? So reducing power increases down the group. So this is halides. See, all element of alkali metal when treated with halogen, it give halide of MX2. Clear? Generally, these halides are of different type from 2 plus 2 to plus 7, except oxygen. See, oxygen form only one halide with fluorine. Uh, Fluorine react with oxygen to give F2O. This is known as oxide. नहीं है ऑक्साइड कब बोलते हैं जब ऑक्सीजन हाँ अब क्लोरीन फॉर्म Cl2O3 ClO2 Cl2O7. These are the three oxides of oxygen with chlorine. With bromine only Br2O and with iodine I2O5. Sulfur form large number of halides except iodine. आयोडीन के अलावा सल्फर बहुत सारे halides बनाएंगे. SF6 S2F10 SF4 S2F2. Similarly with chlorine with bromine. Clear? इनकी hybridization क्या होगी SF6 की? The structure is, what is the hybridization of SF6? sp3 sp3 D. करो. How you calculate hybridization? इतना लंबा मेथड की जरूरत नहीं है. हाँ, the valence, see, count the valence electron. 6. Number of atom by 2. It is 6. Write SPD. This is 6 1 3 2. sp3 d2. So sp3 d2, what is the shape of sp3 d2? Octahedral. Perfectly octahedral. No lone pair. Clear? What is the hybridization of SCl5? SCl4. SCl4. SCl5 is not formed. Again D2. ऐसे calculate करो. Sulfur, the valence is 6. Number of atom attached 4 divided by 2 5. sp3 d1. Triangular, planar. Triangular, but there are only 4 halogens and 1 lone pair. So lone pair is present in axial or equatorial? Equatorial. अगर हम lone pair को axial में रख देते हैं ना तो it repel with the 3 bonds. 3 bond के साथ repulsion होगा. But अगर हम equatorial में रखेंगे तो it repel with the 2 bonds. So these are chlorine, chlorine and chlorine. Okay. So this is the structure of SCl4. So you can able to prepare all the structures of halides. Clear? So these are the halides. You have to remember the nature of halide as well as the type of halide form. We have completed this. Next. Now this is oxides, and oxides are very important. See, sulfur I'm not writing oxygen because we are dealing with the oxide. So these elements react with oxides, O2, to form different type of oxide. See, sulfur, start with the sulfur. When you react sulfur with oxygen, it gives SO2. Mainly, these form 2 type of halide. Okay, 2 type of oxides. One is MO2, second is MO3. Other oxides are also possible, but in general, if you see, these halogens or these metal react with oxygen to form MO2 and MO3. These 2 type of oxides. Now, MO2 and MO3. MO2, in case of MO2, sulfur form SO2. What is the hybridization of SO2 and what is the shape of SO2? sp दोबारा करो, sp2. How many pi bonds? हाइब्रिडाइजेशन में बड़ा कंफ्यूजन है. देखो सल्फर सेंट्रल एटम है 6/2, 3 sp2. sp2, what is the shape of sp2? Triangular planar. So one lone pair, this is oxygen, this is oxygen, this is sulfur forming 2 pi bonds. Okay, so the shape is angular. So shape is angular. So this is the structure of SO2. SO2 is gas. So no polymer form, SO2 exists in this form. But if you see the structure of SeO2, it is also sp2, triangular planar, having 2 pi bonds, but it undergo polymerization and form a solid form. Clear? This polymerization of SeO2 is like this. See this structure. This is cyclic chain of double bond, single bond, double bond, single bond. So, and similarly T and PO. So we can say the MO2 kind of structure, the sulfur form gas SO2 single district unit, whereas SeO2, TeO2 and POO2 exist in a polymeric form of chain like this. Clear? Clear? So I'm talking about how these oxides are formed. How these oxides are formed. This is the type of oxide which I have mentioned. Okay, first we will learn the different type of structure of oxides, then we'll go ahead with the normal peroxides and all that. Clear? Clear? So this is all about the structure of MO2, not oxides. MO2. In MO3, sulfur reacts with oxygen to form SO3. What is the hybridization of SO3 sulfur? sp2. sp2. How many double bonds? Two नहीं है तो 3 तो हो गई. See, first write down the valence configuration. This is 3s2, 3p4. So s orbital consists of 2 electron, p orbital consists of 4 electron. 1, 2, 3, 4. Clear? Make one vacant d orbital. Make one vacant d orbital. Clear? Third step, calculate the oxidation state of this sulfur. Here the sulfur, the oxidation state is +6. +6. So we required 6 unpaired electrons. This method is very good, and this method is also used to calculate the hybridization of coordination compounds. Clear? So this is +6. So we required how many unpaired electron? 6. How many unpaired electrons are present right now? 2. So we have to excite the electrons such that number of unpaired equals to oxidation state of the central atom. So if I excite this electron, now there are unpaired electron are 4. 1, 2, 3, 4. If I excite this electron also, the unpaired electron are 6. And we required 6 unpaired electrons. There are 6 electrons, right? Now, this central atom is attached with how many atoms? 3 atoms. So we required 3 unpaired electrons. 3 unpaired electrons. So count this 1, 2, 3. So these are 3 unpaired electrons. Yes. So this is sp2. Now how many unpaired left? Number of unpaired left equal to number of double bond. So this is, if this is sp2, the shape of sp2 is triangular planar. The shape of sp2 is triangular planar. Number of unpaired left are 3. Therefore, it forms 3 double bonds. Okay? Clear? Clear? Find the hybridization number of double bond in SO4 2-. Number of double bonds are sp3 is correct. Number of double bond. See, this is SO4, 2 minus. First, you have to calculate the oxidation state of this sulfur, which is +6. Write down the valence configuration, 3s2, 3p4. S consists of 2, P consists of 4. And there is a vacant d orbital. Vacant d orbital. So if it is 6, you have to make 6 unpaired. Number of atom attached to the central atom is, so you calculate 4 unpaired electron. sp, how many double unpaired left? That means number of double bond is 2. So make tetrahedral structure having 2 double bonds and 2 single bond. Both single bond consist of negative charge. So the hybridization is sp3, shape is tetrahedral, number of double bonds are 2. Clear? So we are talking about the oxides. Sulfur form mainly two type of or 3 type of oxide. One is SO2, other is SO3. So SO3, the structure is triangular plane. So write down SO3 exists in different polymeric structures. One is single unit of SO3, which consists of 3 pi bonds, and second is cyclic structure. The cyclic structure may be of 2 types. One, it consists of 3 unit of SO3. 3 unit of SO3 combined with each other. Clear? 3 unit of SO3 combined with each other. Now, the combination reaction is simple addition, which you have already read in the organic chemistry. See, this is SO3, oxygen, double bond, sulfur. These are the 2 units. See, between sulfur and oxygen, oxygen is more electronegative, and this is a pi bond, which is weaker bond. So both the electrons are taken by this oxygen. Now this oxygen consists of negative charge, this sulfur positive. These 2 electrons are taken by this oxygen. This negative approaches this sulfur, and this approaches to another sulfur, right? So this way they can be able to form a cyclic compound, which consists of, each sulfur consists of 2 double bond, and the oxidation state remain constant. This is not a redox reaction. If you can able to calculate the oxidation state, sulfur +2, +2, 4, 5 and 6. All sulfur in the 6. This is simple addition. Addition of 3 monomeric unit of SO3.